The idea today is to talk about web development for Java developers. And I know that because I have been selling Java UI development framework for Java developers for ages, usually on the Vaadin booth, the first question is, but I'm not a I'm not a web developer, I'm a Java developer, I don't want to touch that part. How many of you are web developers? Yeah, I know, I guess that, but majority, I guess, like considers yourself as Java developers instead of web developers. And the purpose of this talk is to kind of introduce you a couple of tools that can help you to create web UIs in Java. And usually the de facto standard these days is that you create REST services and then you have a React team that creates you the UI. But there are a lot of places when you need to do that as well, or you would like to do that. But after this presentation, you will have some tools that makes it easier for you to approach the UI part as well. I'm actually originally a UI developer. I was writing web applications early in the millennium already, and I was hired by Vaadin, which is Java company. So we create a Java library to create web UIs, and I joined Vaadin on 2006 or 5. I was kind of hired to finish the so-called Ajax adapter that made our product from like traditional HTML-based, form-based UI framework into single-page application. And then I turned later into Java developer. We started to use Google Web Toolkit on our product as well on the client side, and rest of the framework was in Java. So finally I became kind of a big Java fan, and these days I consider myself more as a Java developer than a web developer. Why JavaScript sucks? Do we have any of those Java developers here who doesn't like to touch JavaScript development? What's your reason there? Why don't you like to use JavaScript?
Don't like the syntax.
Yeah, that's one way to put it. There are multiple reasons why you don't want to put your hands on that part. It's not that bad actually these days. The industry has developed a lot, and if you don't like that syntax, you might like the TypeScript syntax more. That is used, I would say, around like half of the front-end projects these days. They use actually TypeScript and then compile that to JavaScript. But it's still a lot to learn. There is a lot of new libraries on the front-end side. There is different kind of languages. There is at least HTML, then JavaScript at least to some extent, even if you're using TypeScript. Then you'll need to learn about how browsers work. So you need to work in DOM, and then the whole tooling chain is different. You cannot probably use your favorite IDE there. You will need to go to some other, some other tooling chain, and you cannot use, for example, debuggers in the Java debugger that you are probably using on the backend side. So it's about your skills, and these toolings that I will be presenting here, they will help you to get started because you don't need to learn everything. So why should you use Java? Language, that was mentioned here. Well, not only that it's better, but you can only work in one language, and that's one of the biggest reasons why I like to use our product also for my hobby projects that I do on my leisure time. So then I don't need to kind of change between JavaScript and some backend language all the time, and that disturbs me when the libraries change from the UI part to the backend part. And other good reason is like organizational reason. So if your tool chain is only using one language, then you can switch the developers from the backend side, from the business logic to the front end when you need more resources on the UI part. And of course, reusing your existing code. So you are all in Java conference here, so I bet you have a lot of existing Java code that you don't want to throw away. And you know also other Java code that you have done or that somebody else has written and packaged as a good Java libraries. So you can reuse those as well. And of course the skills. So all the investment that you have made into your skills while using Java tooling, Java IDEs, using debuggers, profilers, and so on, all that is usable if you use Java tooling, or almost all of that. And when picking up different kind of technologies, it's always about trade-offs. So these pictures are from my summer paradise that I have been building lately, and I got a nice analogy when planning the talk. So I've been building totally different kind of stairs there as well, and the end result depends quite a lot on what kind of materials you use there. So I cannot use steel outside because it will get rusty because my cabin is next to the sea. So everything will be rusted in a couple of years. And wood is nice, but it would be way too heavy if I would build those stairs that are going to my second floor for some accommodation spaces. And outside, next to the sea, I decided to make the stairs from concrete because it needs to be a bit rough. The sea is frozen in Finland in the winter, or at least the temperature is below the zero, and then the water boils to the cliffs, and it will be very dangerous to walk there if those would be built from the steel or from the wood. But the concrete, that stays, the grip is pretty fine there during the winter as well. And it's also about the price. So they have different characteristics, like how much it costs to build it, and also the end result depends on who is building those. So I'm not very good with concrete, as you can see. It doesn't look very good, but I'm pretty good with circle saw. So I like to build like wooden stairs if it's just good solution otherwise. First tool is JSF that I picked. It's pretty old one, but it's still very valid tool to use, to have in your tool chain. So JSF is actually, these days they like to build called as Jakarta faces, and it comes as a standard piece in all Java EE containers. So it's a very good solution if you happen to be running on Java EE servers. No external libraries are needed. You can also configure that for other stacks, but that's always another struggle then. All the UI logic is actually executed in the server side, so it's very easy to integrate into your existing Java services. So basically you will be just injecting your Java service into your bean that you are using in JSF templates, and that's it. Let's quickly look into some JSF code. So the view is declared in HTML. So this is not kind of poor Java framework. This you need to master at least HTML and Java, but absolutely no JavaScript is needed. So that's a good thing. There is HTML. We are importing a couple of namespaces there. I'm actually using also prime faces here, just as an example, because that's most likely what you want to do with JSF if you are building anything more complex. The core parts, that's very good if you are building just normal web page or block listing or something. Those are just enough for there. But if you want to make like a actual business application, then you need to have another library, or otherwise the UX will be quite bad. So here we have some snippets where we are injecting code from the beans, and the server side then processes this so that on the server side these are swapped, and as a result we are getting only JavaScript. So if we look at the source here, we see some JavaScript that is injected by the prime faces, but essentially this is the content now. So these texts, these are coming from the Java object behind the scenes. JSF is built or designed in the beginning of millennium, so it was designed before the single page web applications kind of broke through. So every time you want to change just like one part of the application, you need to use Ajax. Here I'm using the Ajax rules from prime faces, but JSF brings its own as well. But the problem with these is that these are kind of bolted on top of that request response based thingy. So these are kind of bit artificial changes. So you need to define that what event is going to trigger this Ajax round trip, and then you need to define the listener on the bean, and then you are also defining that, okay, I'm updating this part of the web page. So let's do a change here in the grid. So we are tracking a row, and now it goes to the server, calls that Ajax method, and it updates this web component here that was like hidden and already present on the page. So it's quite hard with JSF to actually change the actual UI, but you can make Ajax based partial updates also, but always you need to design that kind of separately. Let's go back to pros and cons of JSF. Yeah, so it's very easy to take in use in case you have a Java EE container. If you don't, then you should probably look into Spring MVC, for example, if you are on Spring Stack. Super easy to integrate into any Java services that you have created. And the best part of JSF, and the reason why I would pick JSF for some kind of applications, is that it's rendered on the server side. So you saw the full HTML that was produced. And if you have, for example, web shop, then you want to use JSF instead of the other tools that I'm going to show here, because the Google indexing is very important on that case. And Google will punish you if you are using React or Angular or Vaadin kind of tools that render with JavaScript on the client side. The good part is also that it's pretty high-level framework. You don't need to touch the Servlet API at all, for example, so you just work on a bit higher level, and you will be more faster with this tool than going with just pure Servlet and so on. The bad parts, well, you need to know some HTML, and the component set is pretty limited. And yeah, Ajax support, as we discussed, and it's not natively supported by the most common Spring tag these days. So you can actually configure JSF if you want for Spring Boot as well. So you can use Spring Webflow and put it there if you want. Let's take another tool. This is completely different. So this is J2CL. So it's basically the Google Web Toolkit version 3 that never got out. So J2CL is Java to JavaScript transpiler. It's a bit smaller than Google Web Toolkit, where they did also all the optimizations in that tooling, but now this next generation transpiler is just actually making like a intermediate JavaScript first, and then they are using the other tooling that Google has built for generic JavaScript optimization. Mainly that's Closure compiler, and that is integrated in the same tool chain, and that's why the whole library is much smaller than the original Web Toolkit. It's actually in a pretty wide use, like also some older Google Web Toolkit still, and let's check out how that works. So this one is a Tetris game. So this is originally a Vaadin example that I have built, because a lot of people who come to our booth and they are very concerned about the server round trip of Vaadin, and that's why I built like Tetris game on the server side. But now for this demo, I also built it with J2CL. So I took pretty much all the same code. So the game, grid, and Tetrimino, these basically contain very low-level Java code that define the game logic. And then I have the Tetris.java class that actually defines the UI. And this onModuleLoad method, this is called from JavaScript, tiny little bootstrap JavaScript. And here I'm using Java to create the DOM using so-called Elemental API, which is coming from Google Web Toolkit 3, or actually Google Web Toolkit 2. So it's the same API, same library, but yeah. So essentially we are using browser DOM API to create elements and adding click listeners, and here we access the Java logic to the game object, and then in the end we are somewhere here doing, so we are using Canvas API in the browser, and we draw the game state on each step, and that's how it works. So this is compiled into JavaScript and executed in the browser. The good parts of J2CL is that it's pure Java. So everything is Java code. So also the view part is Java code. So you have all the freedom how to structure your UI code. My example was very badly structured, but you can use your existing Java skills there. It's totally independent of the server. So I was actually deploying that with the Jetty plugin, but just because it's handy. You can use, for example, just plain Apache HTTP server to do that as well. And it allows you to execute your existing Java code in the browser. So you don't need to run it in the JVM like with JSF and Vaadin. And it's very close to all the browser's good parts. So if you want to access anything inside the browser's native APIs that you probably don't master that well because you're in this talk, but those are very close. With Vaadin and JSF, you usually need to make some kind of a proxy that goes to the client side and fetches some data there. There you are actually, the execution happens right next to those browser APIs. The bad part is that it's not Java ecosystem compatible anymore. It's not running in the JVM. So it's incompatible with a lot of libraries. Only part of your Java code actually compiles with J2CL. So for example, reflection is out of the game. It's very hard to implement for this kind of system. And for example, latest good language enhancement that we have gotten in, for example, the text blocks, they are not available yet for J2CL. They will maybe come out at some point in the future when Google engineers have the time to implement it. But you cannot get everything else that happens in the Java ecosystem in J2CL applications. The biggest problem that I find currently, why I think that J2CL is not that popular at the moment as Google Web Toolkit was in the past, is that it's using Bazel tooling. Who knows what Bazel is even here? Couple of hands. Who actually has used Bazel? 3 people. Yeah, out of pretty large audience. Majority of us are Maven people or Gradle people, and we are probably quite happy with that tooling. Bazel is a totally different thing that needs you to learn yet another thing. There is a community plugin that I was actually using in this example because I struggled so much with the Bazel tooling. But if you want to get really good developer experience, then you should definitely go to Bazel-based build with J2CL project. Also, it's compatible with the tooling, so you can use your Java IDE to develop the code, and it compiles your Java classes, but you cannot use, for example, debugger. You need to go to the browser side and use the debugger in the browser, and you need to use different kind of profilers. You cannot use Java profilers there. It's very low level. There is no components like that are shipped with JSF and Vaadin, and also there is no templating system, so it's pure Java. I like that. But if you would like to have a HTML templates, then it's a no-go. And yeah, accessing any services, even Java services, that basically needs to happen over REST services. So there is no built-in ways to easily access your Java services. Let's go for Vaadin. So Vaadin kind of combines these different frameworks in a way that we are using the same kind of full Java approach, but we are executing that on the server side, and then we are rendering that as a single page web application. So each component on Vaadin has its counterpart on the client side, and the component's internal logic is executed in the browser, and the actual business logic part, that's only in the server. So Vaadin ships with a big set of UI components, and You can extend those, but at that point you will need to go on the client side. And the difference with both J2CL and JSF is that we are still on a yet another abstraction layer. So when you're developing Vaadin applications, it's pretty much the same as developing desktop applications. Let's look into some Vaadin example, and I will explain also how Vaadin works. Gonna use the same application that we have on the booth. If you wanna later stop by our booth and see how Vaadin works, let's pick this sandbox view. So this is very simple Vaadin application where we have a text field, button, and then we hook some logic here. And then we put that into a horizontal layout, which is also a component. So we are composing new components from existing ones. And then we are adding that into this vertical layout that we are extending here. And this sandbox view is then mapped to certain URL with this annotation. And then we are including some root layout there, but that's a different part. Let's not look into that at the moment. Okay, I don't have that running. Let's run the Spring Boot application here. Vaadin requires just a servlet container, so you can integrate it to your Java EE application or Quarkus application as well, but this one is using now Spring Boot. So here is a set of those components, layouts, forms. Typical Vaadin applications, they are grids and forms. Grid is one of our most advanced components, and this is the sandbox view. So whenever user arrives to this kind of sandbox view, it sends the client sends this URL, of course, to the server side, and then the server decides that okay, we will need to render that sandbox view in here. And same as in J2CL, I think I didn't show it, but in J2CL, the content of the actual page is basically empty. So it's the same in Vaadin as well. This is running in the debug mode, so there is quite a lot of JavaScript available here, but the body tag here is basically empty, so nothing is rendered on the server side. But then the server side sends tiny JSON message that describes this structure that is sent to the server client side, and then the client side thin client basically renders that. And when you interact with this component and hit a button, now it goes to the server, it sends whatever I typed to this field to the server, and executes that click listener here. And in the click listener, we are directly now modifying the existing structure of the view. We could change some text here, but in this case I wanted to add a paragraph so that you can actually see that you can modify the view as much as you want, like dynamically. And that makes Vaadin very powerful when you have like a large flexible UIs that you need in your very complex business applications. So when you have a lot of rules that how the UI should change, it's much more flexible than JSF. And yeah, let's get to the good parts of Vaadin. Let's keep actually this animation because I already talked about that. So there is only Java, and now the Java is much better in a way that it's executed also in the JVM. So all the libraries basically are compatible with Vaadin. You cannot use, for example, desktop things like or actually you can use, for example, some Swing APIs if you want to use, for example, color from the AVT packages. That's fine, but you cannot render anything with that API in Vaadin application, of course. So because it's executed in JVM, you have a lot of power from the server available, and it's compatible with all the code. You have exactly the same tooling. You will, if you want to debug Vaadin application, you will be using your favorite IDE. So you can put a breakpoint in Vaadin code, use the UI, and then it actually stops in the IDE there. You can inspect that how did you write that bug. And also you can use, for example, profilers. And you can use all the libraries that are available. So almost all Java libraries are compatible with Vaadin applications. And there is also very active community, unlike with, for example, J2CL. So we have, for example, hundreds of extensions that are bringing in UI components that we don't support out of the box in the toolchain. And also we have a company that actually can help you if you end up into some hassles with Vaadin. The bad part is that it's an additional dependency. So if you happen to have that JSF in your toolchain, and that is probably kind of, if you're working in some corporations that is making, for example, a lot of money with the banking sector, then I know that you have rules in your company that every dependency needs to be approved beforehand. So you will need to get approval for Vaadin. The bad part, which is also a good part, that it's a single page web application, so it's very good for the UX. You will get much better UX out of the box, but on the other hand, the Google will punish you. Google will actually understand applications like React or Vaadin applications that are rendered, but it can be a problematic, like navigation inside the application. Googlebot doesn't necessarily do that pretty well, and also it is known that Google will punish you if the content is rendered with JavaScript. The US state is on the server side. That's usually a concern by quite many people that, oh, no, this is using a lot of memory. It's not using a lot of memory, but of course it's using more memory than, for example, completely stateless React application. Usually, if you are clustering your application, then you probably want to use session affinity or so-called sticky sessions. So you will want to configure your front proxy so that all the things goes to the same place. That way, you don't need to think about session serializability in your actual Vaadin code. Otherwise, you will need to make the session serializable and share those with all the nodes. And the bad part is that even with Vaadin, you will at some point need some custom skills on the front-end side. So you might want to use JavaScript and web skills when you are building extensions. So if there is something that you cannot really accomplish with our built-in components, then you're kind of out of luck, unless you find those extensions from our directory. So let me show you from if the network happens to work. So this is one of our most popular community services. So people are sharing, for example, the organizer of the event XDev, they are actually providing quite a lot of extensions that they share for free with other Vaadin communities. So XDev. So they have only XDev has 6 different. Oh, that's mine. 5 different add-ons that they are sharing. Yeah, let's get a quick overview of these 3 different things. So JSF, that's half and half. So you need to have the XML template, and the actual business logic and all your services, they are Java. J2CL, that's completely Java, like Vaadin. And JSF, that's completely rendered on the server side, or maybe I could actually have like one empty dot there, because you can make AJAX requests, and at that point a tiny bit of that place is kind of rendered in the browser. So there is tiny bits of JavaScript that allows you to do those AJAX interactions in JSF. In ecosystem compatibility, it's clearly for JSF and Vaadin. So J2CL is kind of, you can use Java, but you cannot use JVM. Abstraction layer, and also like one comment about JVM ecosystem compatibility. So with, for example, Vaadin, you can drop in Kotlin, like we have here one very enthusiastic Kotlin user. So you can use Kotlin with Vaadin because it's in the JVM. We don't support any special Kotlin integrations in the core framework, but there is a community add-on for that kind of makes the API more Kotlin-like. Kotlin DSL is provided there. The abstraction layer, that's definitely the highest in Vaadin, and that's not only a good part. Sometimes it's much better to be very close to the metal, like on the J2CL, which is basically at the very low level. And JSF is somewhere in between, I would say. Integrations, those are easiest definitely to do in J2CL because it's in the browser. And those are actually very easy to do in Vaadin as well. So we have a very powerful so-called element API. So if you want, I could actually show you quickly how it goes. So if you go with Vaadin button, there is a backing get element call here, and this returns kind of a proxy for the browser side element of this button. And now I can set attributes or properties, or I could get the style node and set the color to green. And now if I hit save and go to the browser and find somewhere this, apparently I don't have any live reload on here. Let's rerun this application. So in development mode, Vaadin actually reloads the page immediately. So if you have a dual screen setup, I usually just change something there and then see what happens in the other screen. So now in the sandbox view, our button is green. So this is the way how Vaadin developers create these integrations with like existing. For example, if you find a very nice JavaScript widget, you can make integrations to that using this element API. So that's why I gave Vaadin 4 points, and or three points there. Yeah, executed in browser, yes. Vaadin kind of half because all of the component internal interactions, they happen on the client side. In JSF, most of the things happens in the server side. Components and extensions, Vaadin has very good component set and very active community providing extensions. J2CL has nothing. Safe choice, well, JSF ships with IBM's web server, so nobody has ever been fired by buying from IBM, so it's very safe choice to pick. That's a big popular framework that has been used for a long time, and even though it's kind of considered as old-fashioned, it's still, I would say, very safe choice to pick. J2CL, you are tied with Google. They don't have any advocacy for this project, unlike for example Angular. You are on your own if you face issues with J2CL. The community is very small. With Vaadin, it's still a separate company, but you have that company and you have also the community there. The reality is that your potential front-end developer will hate you for picking any of these technologies. They want to get that React or Angular. They are very happy with that. But with JSF and Vaadin, you can use HTML templates as well to define the view, and then you can kind of put some work for your front-end developer if you have to have that kind of people in your team. The good part is that CSS is used to style all of these applications, and the potential designer or front-end developer, they can use their CSS skills to theme all of these. As a summary and a reminder, kind of that like typical use cases for these things. So where I would pick JSF is something if you're building more like a website instead of a web application. For example, you are building web shop that is mostly website, and it's very relevant that Google indexes all your great products that you're selling there. If they are not visible for Google, you will not have customers. That's why J2CL, Vaadin, React, they are out of questions. Render everything on clean HTML on the server side. That way your page will be indexed much better. Then if you have a very like a dynamic application, big business application, CRM system is very typical use case for Vaadin applications. If you have a lot of interactions and you are inputting also a lot of data, Vaadin is a very good choice for that kind of applications. And then if you need to get really to the metal, and for example, if you would be implementing the good old Duke Nukem 3D game, that would be perfect use case for J2CL. The browser is pretty fast execution environment these days, and J2CL is doing very good job for optimizing your Java code. You can write your game engine in clean Java and then compile it for the browser. But probably, actually, I would make mixes of these. So if I would be creating that game for browsers, then I would probably need some Chrome as well, or some kind of result systems and backends and front ends where the games are listed, and there probably JSF and Vaadin would come into use. And also you should keep in mind that you can integrate all of these technologies with others. So you can embed, for example, Vaadin application in that web shop to do the checkout part, which is clearly more dynamic UI. So you have different support for different credit cards, and the UI changes on the fly, and you don't want to use JSF there, or at least you don't want to use their Ajax APIs to implement those changes that modify the UI on the fly. That's very dynamic UI. That is a perfect fit for the Vaadin part. And in the same way, when you are making a bigger extension, for example, for Vaadin, you could use J2CL to implement that component logic also in Java, and then package that as a Vaadin component that is used actually on the server side. And then the second point there, use the tools that you want to use. So if you want to use Java IDE, use any of these tools. If you want to have the most perfect Java experience, it will be Vaadin. If you want to get a bit closer to the metal, consider also JSF and J2CL. If you are happy, then your code will be better. But if you are just struggling with the technologies that you don't master and you don't want to spend your time on learning those, then the code will be bad. I was actually much faster than I thought. I thought I will overrun at least 10 minutes, but finally it was faster. But this is a good thing, because now we have time for questions. And also, if we don't have questions, then we have time for questions outside. So like in one of those talks, somebody said that the best talks in the conferences are always on the hallway after the talks. But let's start here. I'm sure you have some questions. You can ask my opinions on anything. There, let's start from the front.
I use JSF for our web application. Didn't know Vaadin before. My biggest issue with JSF and drive bases and all this stuff, sometimes something won't work and it won't tell me at all. So, for example, I have a button, I click it, nothing happens.
Yep.
And no exception, nothing. And well, is there something? Is Vaadin better in?
Yeah, I will try to repeat the question so that it goes to the recording as well. So the question was about JSF, like you are using JSF, and there when weird things happen, and it might be that you don't get any clue that what's the issue. And you asked that how Vaadin compares to that. In Vaadin, all the exceptions should always be locked. So because almost everything happens on the server side, that's why the exceptions happens on the JVM, and that's why they are reported at least to the console. And but some of the exceptions, they are also thrown in the development mode to the UI as well. So in development mode you can see the exception in the development mode widget that was actually visible here. But yeah, I would say that that's much more rare with Vaadin, but there has been bugs. So there was bugs in Vaadin 10 and Vaadin 14 versions, which were basically a rewritten Vaadin version after a very popular Vaadin 8 version. So we had some issues that some of those exceptions they were not reported, but that was a bug in Vaadin. So if no issues are thrown, then it should be a bug in Vaadin. Yes, all exceptions should be thrown. Yeah, there was the next question.
Do the Vaadin components come with some default CSS? I assume so. And do they integrate with something like Bootstrap or some external CSS library?
Yeah, so the question was about theming in Vaadin. So do we have some default theme? Yes, this is the default theme that we have currently here. And I'm not sure now if this works because the development mode was not. Let's try. This is actually a new theme wizard. I haven't used it before, but let's try it out. So Vaadin theme is built with modern CSS3, so we are using a lot of like variables. And if we pick, for example, this whole area here, we now get a UI how you can modify that CSS. But most probably your CSS engineer will modify the CSS variables directly there and change the things. So here we can change all the components now. For example, if we want to increase the roundness, now all the components changed. And let's increase the padding. Did nothing actually happen? Yeah. Well, you can see that's a preview. Okay. Yeah. The spacing worked actually pretty well. So if I make it smaller, now it's very small, and if I define it larger, now all the spacings in this area that I picked will be changed. So the theming system is pretty nice in Vaadin, but one issue is that if you have custom component that you have built yourself, that doesn't necessarily work with that theming system, or if you have picked up some of those extensions. But I think all of the newer Vaadin extensions, they can also utilize these basic rules that we have in the theming system. So I think it's getting better there as well. But all the core components work perfectly. Markus has a comment there.
I was about to say you can uncomment some stuff in styles.css.
Yeah. So we can also see the actual theme from here. Let's go to files. The front part. So here we have the theme, and what would you suggest me to do? Yeah. So these examples. Oh. There is probably a way to do it faster as well. So this should now change the whole application. So these are defining those CSS3 variables that we are using in the theme. Oh shit. I don't know how that would work in the CSS. I only know that it works in Java. Let's try that. And now, okay, yeah. Now we can see that everything became red. So the main color was changed from the default to this color that my NetBeans is not showing. I know that IntelliJ would actually show it there, the color, and it would also let you pick up a new color there. But this is the way how to theme Vaadin applications. All right, next question.
Regarding integration of existing backend code in JSF, as you've shown, we have very
Backing bean.
integration using CDI or
Yeah.
anything coming from the Java EE stack. How is it comparing Vaadin to JSF? We have a lifecycle in JSF.
Yeah. Yeah, the question is from JSF user who has been using different kind of beans in their JSF integration. So JSF has very good integration with CDI, and so does Vaadin. It's not with the core thing, but you will need to add one dependency, and then you can use CDI beans in your Vaadin code. And actually, I could show it from, or actually, I'm not sure if we have any. The booth demo, actually we do have some repositories at least here, so this is probably injected somewhere, and we have some service layer. So grid view, here we are injecting the person service. So we are not using the auto-wired because that's not required with Spring, but this is Spring Bean that we are injecting into that Vaadin UI code, and then you can use it from there. So we have official integrations for Spring and CDI and the Quarkus variant of CDI as well. And then there is community integration also to Google Choice framework. Don't remember anything else. All right, next question. I think we still have time. No questions? Templating with Vaadin. Yeah. I think we removed all the templating code from the booth examples. Maybe I could actually show one demo from the GitHub that we had, like previous Vaadin example. It's a bit outdated, I think. Vaadin bakery. Yeah, this was an older Vaadin example, and in this example we are building pretty much everything with those templates. So here we are defining the UIs pretty much like in JSF. So we have views that are basically it's not HTML, it's actually JavaScript, but inside there is mostly HTML. So these are actually lit templates. So you define these using HTML basically inside JavaScript. This is one of the weird things about the modern web development, that quite often you are defining the HTML these days inside your JavaScript files. And that's what we do as well. So this is now bind in, let's take order editor. So then we have a corresponding Java class for that. UI views, what was the name? Well, let's take anything. Let's take this one, for example, order editor. So this is then mapped into that template using annotation, and then these are components that are defined in the template, and they are injected into this Java class. And then when a new view of this kind is instantiated, you can then directly modify these elements in the UI. So here we are actually getting the data from the backend system and putting those into the components and registering the actual UI logic. Okay. Any more questions still? No? So let's quit it here, and we can continue. We can continue maybe later, but I guess you want to cut the presentation here. Yeah. Huh? Sorry? Yeah. I will be spending my time on the hallway at our booth, so if you have any questions, come there and let's discuss about web development.